Earth Day came and went again this year, and that got me thinking a bit about our beloved hobby of 3D printing. After all, while 3D printing does have the potential to actually reduce carbon emissions in various different ways, at the end of the day, we are still producing plastic stuff, much of which will inevitably end up in a landfill. So in this video, I'm going to share 19 practical, effective, and actually accessible ways to reduce the carbon footprint of your hobby, so you can keep on printing guilt-free. Oh, and stick around to the end because some of these might really surprise you. Let's get after it. The first category of improvements and optimizations that we can make involve our choice of materials and accessories. To get the most obvious one out of the way, let's talk real quick about your choice of polymers. Now, as you likely know, most plastics like PET, PE, PP, and ABS are made from petroleum byproducts, which carry a heavy environmental cost, even if they are just byproducts of the fossil fuel industry. And while supply chains, fertilizers, and so on mean that PLA isn't automatically green just because it's bio-based, there is still significant benefit to choosing it. First, it melts at lower temperatures with a cooler build plate and no heated chamber, saving energy during extrusion and printing. But that's not all, because it turns out that nature has created these awesome solar-powered devices that actually capture carbon dioxide from the environment and store it as biomass. They're called plants, and I highly recommend that you try going outside and touching some if you get the chance. Now, I don't want to overstate this point, but some reviews do estimate that every kilo of PLA produced may involve around 1.8 kilos of atmospheric CO2 uptake during the feedstock regrowth, which is flippin' cool, if you ask me. The actual environmental impact is way more complicated to calculate, but bottom line, the carbon atoms in your PLA 3D print come from atmospheric carbon, whereas the ones in your ABS or PETG print come from dead dinosaurs sucked up through a straw. Of course, PLA isn't suitable for everything, but these days we have some pretty incredible PLA-based products such as PLA Pro or Polymakers high-temp PLA, and many more like them. So the next time you think to automatically reach for that roll of PETG, consider whether or not something like PLA Pro will do the job just as well. In addition to choosing more environmentally friendly polymers, you can also opt to buy recycled filament. First, there are now entire companies like Recycling Fabrique and Infill selling 100% recycled material, often on reused and donated spools. But beyond that, many of the major brands like Polymaker, Prusament, Colorfab, and even Filamentum actually already offer filaments made from recycled plastics, fishing nets, and carbon fiber. And according to Prusa, manufacturing their recycled PLA and PETG emits 56 to 57% less emissions when compared with virgin material. So by purchasing these products, you not only save plastic from the landfill or the ocean, you reduce the carbon footprint of your 3D prints themselves, while also signaling to these companies that we hobbyists actually care about this stuff. And in so doing, you're encouraging them to develop more of it. Another pretty obvious way that we can lower our carbon footprint is with our choice of filament spools. Not just the filament, but the actual spools themselves. Today, refill spools are becoming more and more common from brands like Prusament, Polymaker, and Bamboo Lab. And I do encourage you to opt for those whenever you have the choice. But even when refills are not an option, like with some carbon fiber filaments, I encourage you to opt for brands that use cardboard spools and boxes made from recycled material. Not only is it more environmentally friendly than the plastic spools that will likely never actually get recycled, but later on in the video, I'll show you a really awesome way to actually use that cardboard to further reduce your carbon footprint. But beyond just brands that use recycled materials in their packaging, there are a few brands that actually go above and beyond, planting trees or offsetting carbon emissions with every single spool sold. Now, historically, Polymaker was famous for planting one tree for every spool of Polyterra sold, but since their rebranding to Panchroma, I actually haven't been able to verify whether or not this initiative is ongoing. Fortunately, it seems to have had an impact beyond just the 145,000 trees planted to date, because companies like Eureka Filaments and Elegoo have taken note, and they now also commit to planting a tree for every single spool sold. Like I mentioned before, trees and plants in general are among the most energy effective means we have to capture carbon from the environment and just generally make our planet a nicer place. So I would really like to see more brands doing this. And if you agree with me, I encourage you to drop a comment below mentioning your favorite filament brand, or if you want extra credit, tweet this video to them and ask them that they look into it. And the final choice that we can make involves the products that we use to actually 3D print with. Most of the energy required to 3D print something comes not from actually melting the plastic itself, but from heating the build surface and sometimes the chamber to 60, 80, or even 120 degrees for hours on end. Fortunately, today we do have some ways to reduce that energy consumption and replace it using technology. First, we have these new high grip build plates like BQ's CryoGrip series. Additionally, we have cutting edge formulas like the new Super Grip from channel sponsor Magigoo. Now, both of these products are designed to allow you to get better bed adhesion at lower bed and chamber temperatures. Now, other creators have already done more in-depth analysis of the potential energy savings, so I'm not going to go into those specifics. I'll just remind you that if you do pick up some of these products, make sure to actually change your filament profiles in your slicer so that you are printing with those lower temperatures. But if you do need to heat up your build plate and possibly even your chamber, you can reduce your energy consumption even further by printing in batches. After all, it's really not efficient to heat up the entire bed and chamber to print a small handful of ABS parts at a time. Now, if you trust your printer, or you at least have the exclude object feature enabled, do try printing batches of larger parts to reduce this thermodynamic waste. So those are a handful of the ways that we can reduce the environmental impact of our 3D printing through making better choices. But of course, there is still considerable impact associated with the hobby. So now let's change gears and talk about how we can offset some of that impact. The first, and by far the easiest way to just offset your carbon footprint is, of course, to pay someone else to do it. And no, I'm not talking about some opaque carbon credit system where you buy some company's unused imaginary carbon credits to just feel good about yourself. I'm talking about literally paying someone to remove a measurable amount of carbon from the atmosphere on your behalf. Now, there are plenty of reputable and trustworthy ways that you can actually do this. If, for example, you care about reforestation as well as carbon capture, then you can work with the same organization that companies like Elegoo do and make a one-time or monthly donation to onetreeplanted.org, who will do all of the incredibly hard work of planting the right trees in the right ecosystems at the right time to have the biggest impact. If, on the other hand, you want to help fund future technologies that might lead to an environmental breakthrough, you can sign up for a monthly subscription to Climeworks, which is not sponsored, but I will share a 10% off referral link if you're interested. I don't earn anything from it. Now, Climeworks offers 3 different mixes of nature-based and technology-based carbon removal. Personally, I use this one because I really like how they give me a dashboard where I can see how much carbon I've paid to remove and how much has actually been removed. Or if you want a more diversified mix and don't mind as much about the actual trackable impact, you can check out TerraPass, who allow you to make a monthly donation in support of their wide portfolio of carbon emissions projects, from reforestation to emissions reduction initiatives and much, much more. I'll link all of this in the description. Now, these services aren't expensive. I think I spend like $25 a month on Climeworks, and they're actually reducing your carbon footprint in a real and measurable way. So if you do a lot of 3D printing or flying, I recommend you check them out. Another surprisingly impactful way to reduce your carbon emissions is actually by composting. It turns out that when our food waste undergoes anaerobic decomposition, like in a landfill, it emits methane, which is something like 80 times more harmful for the environment than CO2 over the first 20 years. So a very practical way to prevent that from happening is just to compost your own food scraps at home. But it actually gets a whole lot better, because you know what every compost heap needs a lot of? Browns, or high carbon dead materials, to balance out the high nitrogen greens of your kitchen scraps. The thing is, most of us don't produce a lot of sawdust, nor do we get a daily newspaper delivered to our doorstep. Fortunately, this is where 3D printing can help us out, like a lot. So a while back, I started tearing up all of my different filament boxes and cardboard spools and tossing them into my home composter. Now, because they're generally made from recycled materials, they end up breaking down really nicely. And I have to say that the quality of my compost has improved immensely now that I have a whole lot more browns. It's really a double whammy. And in case you're worried about the glues that are used to bind the cardboard together, I did reach out to Polymaker and I had them look into it. Now, of course, I can't speak for every cardboard spool manufacturer, but according to Polymaker, their suppliers use either cornstarch or PVA glue and always eco-friendly ink. Now, neither of those things should be harmful if composted and then used in your vegetable garden, but I'm not a scientist or public health official, so if you want to be safe, you can just soak the cardboard in warm water and rinse it out to pull out all the glues before you tear it up. This has the added side benefit of making it a whole lot easier to tear into manageable chunks. Or if you want to be extra safe, you can choose to only use this compost on things like your flower garden and non-fruit bearing trees. And for those of you who are already making excuses like, I don't have a garden, just don't. Today, you can buy really nice and compact composting setups that can live on a balcony. Heck, in my last apartment, I didn't even have a balcony, so I just donated a composter to the roof of my building for everyone to use. This one thing makes a really outsized impact, and it's not hard to do, so please, no excuses. Now, another less obvious way to offset our carbon footprint is by actually using 3D printing to fix stuff that would otherwise end up in a landfill. I don't know about you, but ever since I got a 3D printer, I see the products around me in a whole new light. No longer do I see a complicated assembly that I'll never be able to find replacement parts for. Instead, I see an exciting challenge and an opportunity to improve my CAD skills. From fixing the never-ending stream of broken children's toys that seem to come my way, to upgrading or modifying an older product instead of just replacing it. 3D printing gives us a ton of opportunities to reduce our consumption. And while you might not be able to directly measure the impact of this, it definitely has one. And when you do go hunting for various things to fix and repair around the house or the office, you're going to want to make sure that you have some high-quality tools to aid you in assembly and disassembly. And that's where this video's sponsor, Hoto Tools, comes into play. You've seen me using Hoto Tools on the channel for a long time now. I absolutely love their compressed air capsule, their snap block series of screwdriver, rotary tool, and precision drill. Heck, I even love their tape measure and their portable mini screwdriver. But the tool that I find myself using the most consistently has got to be this, the Pixel Drive screwdriver. Now, why, do you ask? Well, first, because it is the only handheld screwdriver that I've ever used that actually has enough torque to actually get the job done. We're talking 6 Newton meters on the highest setting. But more than that, it has 2 speeds and 6 adjustable torque settings, so I no longer strip or break screws, which y'all know I do be doing. Plus, with USB-C quick recharging, it's always ready when I need it. But like I said, I do love their entire lineup of tools because it is all just really well made with a ton of attention to detail and thought when it comes to design and ergonomics. So I've partnered with Hoto to give you guys a 10% site-wide discount on their entire range using the link and the coupon code in the description. And with Father's Day coming up, you might just want to pick up some stuff for the dads in your life. Or, let's be honest, send the link to your wife and tell her what you want. All right, let's get back to the video and talk about recycling and reusing. It's no secret that nearly every common 3D printing filament is not actually recyclable in commercial recycling facilities. But even if it were, and even if the majority of plastics that you designate for recycling didn't actually end up in a landfill somewhere anyways, without proper markings, it will just never be recycled. And that means that it's on us to ensure that our 3D printing waste gets put to good use. The first and obviously most ideal way is to actually recycle your filament right back into new filament, giving it a completely new life as whatever 3D printing widget you need to print next. And with more and more desktop and consumer recycling products coming to market, this is finally becoming more and more affordable every day. Gone are the days when you need to do what I did and spend thousands and thousands of dollars and weeks of your life welding and building your own entire setup. And I really do hope that products like the Loop or the Creality M1 are going to actually deliver on their promise. A side note on that, many of you have asked, and I am hoping to get my hands on both of those, plus another extruder model from another one of their competitors very, very soon. It's been a little bit difficult logistically with everything that's going on in my part of the world. But I'm also, in the meantime, currently experimenting with this desktop injection molding machine from Plasticpreneur as a means of recycling the more contaminated 3D printing waste. So get subscribed if you're interested in any of that. I care a lot about this and I'm gonna keep covering it. But by the way, you don't actually have to make filament to meaningfully recycle your 3D prints. There's no shortage of ways to actually do this, so pick your poison. You could melt your 3D printer poop into silicon molds like Uncle Jesse showed in a video a few years back. You could use a sheet press to turn failed prints into large sheets like Michael of Teaching Tech has done, or you could use the method recommended by Brothers Make and combine a panini press with some wooden molds to make beams. Heck, you honestly don't even need to melt the material down to actually recycle it and give it a new life. You could shred small pieces in a high-quality blender or a 3D printed shredder manually, and then use that regrind instead of adding extra virgin material to beef up the weight of your prints. My point is, there are plenty of creative ways to actually recycle your filament into something new, so don't get hung up on expensive extruder setups if you don't have the budget or it doesn't make sense for you. Just start experimenting. Just please do it safely. But of course, recycling your own filament does still require some equipment and some time, and not everyone has those things. Fortunately, you don't have to go it alone. Although the big names in 3D print recycling, companies like Recycling Fabric, are not yet accepting waste from anyone and everyone worldwide, slowly, there are more filament recycling centers opening up all over the world. In fact, Prusa Research already hosts a world map where such centers can register to begin accepting 3D printing waste, and there are already over 100 of them worldwide. We'll go ahead and link down in the description, so if you are one of the many people in my audience who has been saving your 3D printing waste and you don't see yourself spending $1,500 on your own recycling setup, I highly recommend that you drop a message to the recycling center nearest you. And for our final category, let's talk about ways that we can reduce our use of plastics and printers, eliminating as much of that waste as possible. The first one is an easy win. Lower your perimeters and infill. Most slicer profiles default to 15% grid infill, but for the majority of things that you would print, that's actually way more than you need. Unless you're compressing the print, most of the strength actually comes from the perimeters, not the infill. And infill is primarily needed to support the walls as they're printing. So instead, consider lowering the infill percentage or using an adaptive infill pattern like Support Cubic, which strategically varies the infill based on the necessity. And for parts that really don't need compressive strength, just switch to lightning infill. As for perimeters, I know how easy it can be to just go ham and increase them anytime you want a margin of safety, but I'll just remind you that these plastics, particularly PETG and PLA, are incredibly strong, like way stronger than we need for most of our applications. So just think twice before you click up and print with 6 perimeters. Another great way to reduce your filament consumption is by just minimizing the use of supports and brims. The best way to do this is, of course, by orienting your parts optimally, and wherever possible, if you're designing something, design it in a way that minimizes the need for supports. Another huge source of waste in 3D printing is from print failures. And there's nothing more wasteful than waking up to a bed full of spaghetti. Now, some of this is, of course, unavoidable. Layer shifts happen, items detach from the bed, though they do detach a whole lot less when you use a high-quality bed adhesive or one of those high-grip build plates we talked about before. But at least we can minimize the waste when they do inevitably happen. One way to do this is by enabling your printer's built-in AI failure detection and authorizing it to automatically pause the print, which not all printers are set to do from the factory. If you don't have AI failure detection on your printer, see if it's compatible with a software like Obico or Octo Everywhere, which adds external failure detection capability to a lot of the most popular printers on the market. And then go in and authorize it to pause your print if you're going to do long overnight prints, or at the very least, configure mobile notifications on your phone so you can check in and either stop the print if necessary or cancel that one object. Another big source of waste in 3D printing is reprinting things like prototypes or imperfect prints. And I don't want to name and shame, but I do know some people espouse a design philosophy that incorporates reprinting dozens and dozens of prototypes to get to the final version. And to be sure, there's no replacement for actually printing out a prototype and holding it and testing it in the real world. But like Christopher Helmke, a designer that I really respect, recently explained on Yontech Engineering's channel, you can reduce a lot of that if you just sit down and really fully think through all the different problems before you hit print. Sure, it takes a little extra noggin fuel, especially for the ADHD prone among us, but at the end of the day, it's both faster and more efficient than a series of multi-hour prints every single time you make a change. In addition, one thing that I often do, both on parts that I'm designing and on those that I've just downloaded, is to just modify the print rather than reprinting it entirely. If something is a tight fit or obstructing in some way, I might drill it, hit it with a rotary tool, or just use a blowtorch and soften the plastic to get it to fit. If it's loose, I might use a layer of tape or hit it with a coat of spray paint to tighten things up. Yes, that means that a lot of my projects are imperfect or uglier under the hood than they would be if I just reprinted. And yes, I do often forget to make the changes before publishing my designs on printables. I'm sorry. But at the end of the day, I save a ton of print hours, a ton of my time, and a whole lot of filament by just settling for a little bit of handmade imperfection in my finished projects. Now, another similar thing that you can do is actually design your parts for repairability. If you know that a part is likely to get worn down or broken, make it a separate removable piece of an assembly. If you anticipate needing to adjust or remove parts, then design for heat set inserts to increase the part's longevity. Sure, it's super easy and super cheap to just reprint the entire thing when something gets damaged, but it's also incredibly wasteful. Another super wasteful part of 3D printing involves drying your filament. I mean, just think about it for a second. We leave a roll of filament out, or we print it without a dry box, we let it absorb a whole bunch of moisture, and then we use a 200-watt AC heating element for 6 to 8 hours to remove that little bit of moisture. And then we do the same thing over and over again every time we use the filament. So instead, you can save a ton of energy by doing one of two things. First, as this very clever commenter suggested, we can actually dry our filament or even our desiccant by simply placing it in the bottom of a hot 3D printer chamber while we print. Free filament drying. But more than that, we can save a lot of energy by just keeping our filament dry in the first place. That means printing hygroscopic materials from a dry box and storing filament long-term in a dry cabinet. Now, to that end, I recently spent weeks testing and tweaking a very exciting way to keep filament dry using as little as 3 watts of power, and the results were very surprising and very exciting. So you can check that video out right here. That's all for this week, but I'll see all of you on the next layer.